We got two customers, same topology which we discussed in the previous class. In the core, the blue circle, the core is our ISP core. And the IGP protocol is important. You cannot run any IGP, you should have only link state routing protocol. That's the very first thing. Link state routing protocol. If it is a large ISP, ISIS is recommended. If it is a big ISP, ISIS is recommended. But many are comfortable with OSPF. They may also go with OSPF, provided they do proper summarization, multiple areas between ABRs, all the stuff. If they're ready to do that, then no problem with OSPF. Now, after having ISIS, we need to make sure the router IDs of the routers are pingable, meaning like OSPF, like ISIS and BGP, MPLS that you're going to enable will also pick the loopback interface address as the router ID. If that router ID is not pingable, then LDP neighbor will not come. So make sure to enable the link state routing protocol even on the loopback interface to advertise the loopback interface network. Second step is enabling MPLS LDP. In some vendors, you need to enable just MPLS that will enable LDP. In some vendors, you have to do separately, MPLS separate, LDP separate. Most of the vendors, you have to do separately, MPLS separate, and then LDP protocol separate. The job of LDP is to only distribute the label. Fine. See, this point is very important when we go to segment routing. In segment routing, we will use MPLS, but we will not use LDP. LDP is not needed. That's the advantage of segment routing. When we go there, we will discuss more. Once MPLS is fine with all the labels, we need to form IBGP between the P's. Only between PE. Only between P's. We form IBGP. After which, we need to also enable VPN v4 under IBGP, called as MPBGP. VPN v4 is one of the family under BGP. This will negotiate the tunnel with the help of reachability that you already have between the PEs given by link state routing protocol. Now, once the VPN is up, next what you need to focus on the customer side. What do I mean by customer side? On the PE router, what all needed for a customer to be accommodated? Customer needs a dedicated routing table. By default, there is one routing table into which all interfaces of the routers are members. Now we need to create another routing table, and only the link that goes to customer need to be placed into it. We use VRF to do it, virtual routing and forwarding, which is also called as VPN instance and various other vendors. Now, VRF is a control plane that connects to the VPN, which you already have. When you configure VRF, automatically one end of the VRF is connected to the VPN. The other end only you have to connect. What do I mean by that? We already have a VPN. This is the VPN. Now, whenever you create a VRF, this is one VRF for Orange that is connected to this VPN. When you create another VPN, another VRF that is also connected to this VPN. Any VRF you create, it will have a connectivity to VPN. We no need to do this connectivity. It is connected by default when you create VRFs. What we need to do is we need to take the interface of the customer. We need to take the interface of the customer, put it as a member of this VRF. We need to say this F01 will be member of this VRF. This is what we have to do. VRF membership. No need to worry about connecting VRF to VPN. It is taken care of. It's already there connected. Any number of VRF you create, they will have connectivity to VPN. So VRF is not a separate entity. VRF always works with VPN, and VPN always uses only VRF, not the global routing table. VPN always uses only VRF routing tables, not the default global routing table. So without VPN, VRF is useless. I cannot say useless. Then you need to go configure VRF on every router in the path. We call it as VRF Lite. That is not practically seen in the real world. See, if you have two routers back to back, PE routers, assume you don't have anything like this background. You just got this router connected to this router back to back. Then you don't need VPN, you will go with VRF Lite. But when you have a VPN, it will always look for VRF tables. And when you have VRF, if there is no another VRF in the neighbor switch, it will always look for VPN through which it can find the VRF on the remote site. That is why in some vendors, they don't call it as VRF, they call it as VPN instance. Brown is one instance, Gray is one instance. VPN instance. This is one instance. The brown is another instance. VPN instance. So we create VPN instance. Which is also called as VRFs. And then assign the customer interface to the respective VRF. Right now, after you do that, between the customer and the VRF of the provider side, you need to have routing either using routing protocol or static and default routes. So I will write as CPE routing. That's all. When you do these 7 steps, you will be able to ping between the local office and the remote office. So the last step which I said, CPE routing, that's not that easy if you have different protocol. If you have BGP everywhere in customer, no problem. Let's say this is BGP 100, this is BGP 200, this is BGP 300, 400, 500, no problem. Easy CPE relationship. Routes will get redistributed automatically into the tunnel and from tunnel to the customer VRF. But whenever you are going to have OSPF or ISIS or RAPE on the customer side, then you have to redistribute from those routing protocols into VPN. And all those routing protocols should be VRF aware routing protocols. Did you understand all this thing that I spoke, David? Okay, okay, that's nice. So about the RT and RD, we have already spoken. Do you have any question on that? Okay, fine. Now, there is another VPN that MPLS can support. We call it as VPWS, Virtual Private Wire Service. This is a layer 2 VPN. This is also called as point-to-point layer 2 VPN. You see similar topology I'm going to have. This is ISP with many routers inside. And it's a full mesh. And now, let's say we got some customers, green customer and orange customer. And they want a layer 2 connectivity. They don't want ISP to provide them an IP address. They don't want IP address from ISP. They want only a tunnel. The customer needs only connection between these two sites. You see, you don't need to create a VRF for this. Why? Because it is layer 2. VRF is layer 3 instance, layer 3 VPN. This is layer 2. Yeah. Customer says we will take care of IP address. Customer 2 head office. Customer 2 branch office. Customer 1 head office. Customer 1 branch office. So customer says you don't need to worry about routing. Customer says to provider, I don't want you to take care of my routing. We will do routing whatever you want. You just provide a layer 2 circuit. You provide a layer 2 circuit. You just provide a wire. You see, wired service, virtual private wired service. You just provide me a wire like this. So how many wires? For each customer, one wire. That is why it is called as point to point. How many VPNs in this picture? 2 layer 2 VPNs. 2 VPWS circuits. One for each customer. Now this customer is having IP address, let's say 10.0.0.1, 10.0.0.2. And here you may have one, or let's say 16, 10.1.0.016, 10.2.0.0/16, 10.3.0.0/16. So he is running, let's say, RIP here. Here also he runs RIP version 2. And he got here 10.4.0.0/16, 10.5.0.0/16. So there are 6 LAN local area networks, 3 in the left and 3 in the right. And there is another subnet in between to connect between the sites. Yeah. So we got these subnets. We want reachability between the head office and the branch office of Orange. Now the green may also have same subnet, doesn't matter. Even same IP address also, no problem. It won't conflict. You see, that is customer's wish. They can have, this is a layer 2 VPN. Customer can have any network that they want. ISPs are not going to read the layer 3 header. All that they need to provide is a layer 2 tunnel. Now, what is layer 2 tunnel? If this router head of is green, send an ARP request asking for the MAC address of 10.0.0.2. ARP request is what? Layer 2 broadcast. That broadcast should go to this end and learn the MAC address. ARP reply should come here. And in the ARP table of head office, I should see the MAC address of the branch office, which means they are in same local area network. When I ping from head office to branch office, it goes through a very big network, but none of the routers are considered because the traffic goes through a layer 2 circuit. This will be very interesting if you do the lab and capture a packet in a Wireshark and see how the packet will look like a layer 2 tunnel. Now, how this is possible? What are all the things needed? Same like layer 3 VPN, you should have in the core with any link state routing protocol. MPLS. MPLS. That's all actually you need. And then now you need to come here to the customer's interface. On the customer facing interface, we need to negotiate a layer 2 circuit. Configure layer 2 circuit parameters. The layer 2 circuit ID should match on either side. Say for example, for green, I'm going to give ID 100. It should be same on both sides. For orange, I'm going to give ID as 200. The ID must match. And obviously the encapsulation type is going to be MPLS. For that, what is very important to know is you need to know the router ID of P1 and P2. You need to know the MPLS router ID of PEs to negotiate layer 2 circuit. When the negotiation is successful, see, if the negotiation need to be successful, what is important is the reachability. PE1 should ping the loopback of PE2 using PE1's loopback. So loopback to loopback reachability should be there. See, there is no BGP needed here. Do you have any question? Or do you want to see this lab? See, there is going to be an encapsulation, but it is not BGP negotiated VPN. BGP is needed there because you are doing layer 3 VPN. You need a layer 3 protocol. But the BGP is an application layer protocol. It's also a routing protocol which works for layer 3. So you need a layer 3 address family VPN v4 to provide you the service. But this is just a layer 2 level VPN. You no need BGP to negotiate. Using the reachability provided by the ISIS or OSPF and the labels that are provided already in the MPLS forwarding table, using which they can negotiate tunnel, which can do a layer 2 encapsulation. This is not layer 3 encapsulation, this is layer 2 encapsulation. Again, you will have two layers of MPLS, same like layer 3 VPN, two layers of MPLS and two layers of layer 2. But the second layer will not be seen because you are going to use a label, the transport label and the service label. When I do the lab and show you, capture a packet and show you, will understand better. Do you want to see the lab for this? Okay. BGP. Same LDP is deployed here to distribute the label. Yeah. Yes. You will have both. You want to see? Okay. VRF is not at all needed here, though you have two customers. You're not going to have routing on the PE router. R2 and R4 are PE routers here. Because we are not going to do routing, we no need VRF. What you need is a virtual circuit, a layer 2 data plane. All right. You see, I have already configured a layer 2 circuit between head office of A and remote office of A. Now we are going to do for this customer B, head office, customer B, remote office. This I'm going to do now. So I'm going to turn on only this router first. Later I'll turn on the other router. As of now, I just want to turn on this. Let me bring the customer routers with all the necessary configurations. I'll use Notepad to configure this. On the customer side, you don't need to do anything for this VPN. Both in layer 3 VPN, layer 2 VPN, Customer has got no idea about the VPNs. It's only the provider service. Customer, as usual, he has got the IP address and normal routing if anything necessary. No MPLS, nothing. Okay. Now I also want to enable telnet so that I can telnet and prove with which device we are interacting. Okay, this I'm going to put it on all the customers. Fine. Now, if I'll ping from here to 192.168.02, I'll not be able to ping because the layer 2 circuit is not still given by our ISP. It is not given. Let us now go to ISP and bring a layer 2 circuit between R2 and R4. You see, between R2 and R4, I'm already having MPLS LDP neighbor. Show MPLS LDP neighbor. You see, I have between 4 and 2. This is actually via VPN. I already have one VPN for this customer. But let us not focus on that. I'm going to create another VPN for this customer B. For that, what I do is interface the facing customer is this. No chat, no IP address because it's layer 2. Same way on router 4. Okay, no IP address. Let us now configure that one single line configuration which brings the VPN. Xconnect. Almost all vendors have got same command only, Xconnect. Who is the peer? For R4, peer is 2.2.2.2. What is the ID you want to give? I'm going to give, for customer B, I'm going to give 222 as the ID. This ID should match on the other side also. What protocol you want to use for encapsulation? See, without MPLS, you can use L2TP, but that is layer 2 on top of layer 3. L2 tunneling protocol over L3. We don't want that. We want MPLS. That's all. Now let us verify show xconnect all. You see, this is down, which I just created. It is down. Do not focus on this. This is created long back in another batch. That is for customer A. Now with the triple two, it is down because the other side is still not configured. Let us go to the other side. Xconnect 4.4.4.4 triple two encapsulation using MPLS. Done. Now, if you go and check the xconnect command, the tunnel will come up. Show xconnect all virtual circuits. You see now this is also up. How easy it is, you see. Both the end, segment 1 and segment 2, they are up. Both the end it is up. Now, you go to the head office and try pinging. Earlier when you ping, it was not pinging. But now if you ping, it will ping. I want to now capture a packet between R2 and R3 and show you. This is the important place to focus. I'm going to ping and show you. I'll ping again. You see. Packet is going from the original source. See, it's an ICMP packet I'm pinging. And it is going from the original source 192.168.1.0 to the destination 192.168.0.2. And this is the original source MAC address. Original source and destination MAC address. This will never get changed. And here there is a pseudo wire, which is nothing but virtual circuit, with two layers of MPLS. One is the transport, another one is the service. The transport is 301. 301 is the label given by R3 for the network 4.4.4.4. Let me show you. Go to router 3 and check local label for 4444. Show MPLS LDP binding table for 4.4.4.4/32. You see the local label is 301. That is what you saw here. 301. This is for switching in between the routers within the service provider. This is the label given to the customer. Customer B's label is 404. This is given by whom? It is given by R4. Let's go to R2 and check that. Outgoing label. Show MPLS forwarding table. You see 204. This is the layer 2 VPN. A point-to-point VPN connected on F01. For all traffic coming from customer B, the label is 204. What about that label on R4? Show MPLS forwarding. Here, same 404. Yeah, for each customer, one label is given. Now, what is next? You have stacks of MPLS. This is the VPN label. So bottom of a stack is 1, which means there is no more label. This will keep changing. The upper layer MPLS will keep changing every hop, but this will be popped off once it reaches the final tunnel endpoint. And this is the MAC address of the routers within the ISP. Whereas this is the original MAC address of the customer source and customer destination. That is preserved. Layer 2 address is preserved here. That is why it is layer 2 VPN. Whereas in layer 3 VPN, you won't find this header preserved. The selected line won't be there in layer 3 VPN. Do you have anything to see here? You want me to show anything here other than what you have seen? Hmm, hmm. IP will be preserved. IP will be preserved, not layer 2 address. Hmm, 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 hmm. See, wait. I want to ask you a question. You have one computer here, and you have a switch here, and you have another computer here. Now, because I'm pinging from 10.0.0.1 to 10.0.0.2, will you call this as layer 3 communication? Then how come this? Mhm, mhm. No, this is service label. Service is VPN service. This is VPN label is service label. This one changing hop by hop. It is transporting. That is transport layer. That is bottom of a stack. How many stacks you can have? It depends on the service. But in any type of service you have, only two you will find. You won't find the three. Right. Even if you take traffic engineering, you will have two only. Segment routing also will have two only. Yeah. All right. Now you see, I'll close this and then I will show you something there. Now I'm going to on these two routers. Now we know that both the customers have got same subnets. But when you telnet from one customer to the customer's remote office, it will go only there. It won't go to the other customer at all because the virtual circuit is different. You already understood, but I just want to show you as a proof that customers both in layer 3 VPN and layer 2 VPN, they can have same subnets that won't cause any conflict. Okay. Now I'm going to customer B's remote office and I'm going to say telnet 5.5.5.5 with a source interface loopback 0, which means I'm telnetting from 1112 to 555 from B. And I should not see customer A router. I should see only customer B router. You look at this, you see only customer B router. When I put the same telnet command on head office of customer A, you will see only customer A. You see, here you see only customer A. Hey, no. What is this? Destination unreachable gateway or host down. What is this? Oh yeah, I don't have routes. Okay, we don't have a route. We need to write route. What about this one? Oh, this one was also saying the same thing. Sorry. I mean different thing. Let us first now have a routing uh, between head office and branch office. I'm going to run rip on all the routers. Rip on all the routers. So enable config t router rip version 2 network 92.168.0.0 network 1.0.0.0 no auto. This I will put it on head office of A and also had a remote office of A that also remote office of B that also got 1111. So remote office of B. And this will be 5. I'll put it on head office of B and remote office of A. Done. I'm expecting now the routes to be learned. Let me go to B's head office and check the routing table. I have learned 111. Now I can do the telnet which I was trying earlier on remote office. I was trying a telnet. Yeah. Username it is asking. I'm going to say username is ABC. Password is 123. You see, I'm seeing from the remote office, I'm seeing the head office of B. And now going to the head office of A, where I was doing telnet earlier. ABC is the username. Password is 123. Now I am seeing only the remote office of A. Here I am seeing a remote office of A. Here I am seeing the head office of B, which means it is working fine. There is no conflict even if the customer have got same subnet because you have two separate virtual circuit. Let's see that one more time. Show not only two separate, this one, they also have two separate VPN labels. You see the number of packets used for both customers because I was doing telnet, right? You want to see this will grow now. I'm going to telnet again from A. Now if you go, you will see more increased in number. Earlier it was 6664. Now you will definitely see something more because I was typing something for the customer. Okay, so that proves that this label has been used. 400 has been used. So labels are different. Circuit is different. This is circuit number 1. This is circuit number 2. But the VC ID which we give is not 1 and 2. Show X connect. Show X connect all. The circuit IDs that I gave is 100 and 222. But this is the first circuit. This is the second circuit. Fine. இப்போ